Good evening everyone. This is Venu, counter lecturer in mechanical engineering from GMR Polytechnic Urnur. So in the last class we have discussed regarding the jigs and the fixtures. Press tools, the jigs and the fixtures. So in continuation of that we are going to see the locators. So observe this picture. See, you are seeing a locators, the clamp, movable jaw and a solid jaw, and the bottom one is on vice body. So what we will do, there is a solid jaw, that is nothing but a fixed jaw, and movable jaw, locators and the clamp. So we will move the movable jaw with the help of an handle or something else, such that it will move towards the solid jaw. We will keep the workpiece in between the clamp and the locators. So this is the vice. So the top figure and the bottom figure, these both are the same, except that is the line diagram and this is a solid figure. Here also you are seeing the fixed jaw and the movable jaw. So clamp and the locator, in between the workpiece is placed. Here the vice is fixed to the table. It may be with the help of an T-bolts or the U clamps. Now we will see regarding the location. So it refers to the establishment of desired relationship between the workpiece and the jigs or the fixture. What does it mean? It refers to the establishment of a desired relationship, that is between the workpiece and the jigs or the fixture. So correct location influences the accuracy and finish of the products. So correct location that influence the good accuracy and the and we will get the good result of the finished products. So the jigs and fixtures are so designed that all possible movements of the component during mixing action must be restricted. See here, the jigs and the fixtures are so designed for this purpose, that all the possible movements of the component during the machining action must be restricted. That means the jigs and fixtures which are designed for some purpose or some special tools or some special work pieces. So only those are to be used here. The locating parts are to be determined to restrict the movements of the component. So the possible degree of freedom of the component are to be found out for the determining the location parts. See a fixture using the milling. On the table, a fixture is fixed. So now we are going to see regarding the principle of location. Principle of location. It is the process of determining the locating the points to restrict the movements of the components with a jig or fixture. So it is nothing but determining the location of the part to restrict the movements of the components with the jigs or the fixtures. So if we locate or if we fix the particular workpiece, it won't move. It will fix it like that only, such that there will be a good accuracy during the finishing. So now we will see the degrees of freedom. I am making the zoom. See that figure. X, Y, Z, and it is a positive, and X, Y, Z is the negative. And also you are seeing the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up to the numbers. So that is nothing but a rectangular block. So which consists of 1, 2, 3, 4, 5, 6 sides, which the arrow is showing here. So that is the positive and the negative. So 6-point location of a rectangular block. See here, the 6-point location of a rectangular block. 6 point location of a rectangular block. See the figure 1, 2, 3, and the bottom also you will see the 1, 2, 3. Start locating surfaces. So the 6 point location of the three-legged object. Three-legged object, that is nothing but an which is in the Y shape, that is nothing but in a three-legged object. So you are seeing a 6 point location, that is from the A, B, C, D, E, F, G. So the three, with the help of an 3 points, we are locating the point. This is also the same figure. Just the top figure and the bottom figure, only the change is here you are seeing the V-typed edge. So here also you are seeing the V-typed edge on the both sides. So location of the cylinder, a round component on a V block. See the figure? Location of the cylinder, a round component of a V block. To hold the cylinder or to hold the cylindrical workpiece, we will use the V-shaped vice or the V-shaped objects or a V-shaped blocks we will use. So those three figures are the same except the side view and the front view. So clamping of a cylinder, a round component. See, this is the figure. I am making a zoom. In the figure, we are making a clamping. We are clamping of a cylindrical workpiece, which is having the diameters of the D1 and D2. So we are clamping. Why we are clamping means it should undergo for the working. So the principle of location, the principle of minimum locating points, only the minimum locating points should be used. Here we should only use the minimum locating points to secure the location of the workpiece in any one of the plane. That means, so it should not get disturbed while doing the or while performing the operation. The workpiece may get strained if more than the required number of locating points are provided. So the workpiece may get strained. Why? If we keep more than the restricted number of the locating points. Example is a 3-to-1 principle. So see the figure, the locating surface. The principle of mutually perpendicular planes. The principle of mutually perpendicular plane is nothing but a 3-to-1 principle. So in the 3-to-1 principle, the three planes supporting the workpiece are not parallel but are mutually perpendicular to one another. So in the 3-to-1 principle, the three planes which are supporting for the workpiece, those are not parallel but they are perpendicular to one another. The workpiece will tend to lift due to the wedging action when the planes are not perpendicular to one another. So what will happen here? When the planes are not perpendicular to one another, the workpiece will tend to lift due to the wedging action. So the principle of extreme positions, the locating point should be placed as far away from one another as possible to achieve the greatest accuracy in the location. So the points which we have to locate, that should be placed or they should be placed away from one another. Why? Because they should not keep near by near or side by side or one by one, like that we should not make. The main thing we have to consider is we have to place it as far away from the one another as per the possible to achieve the greatest accuracy. So this is to ensure foolproof, that is the workpiece is loaded in the correct position. So, see in the figure 001, offset has little effect on the location of the part. A, that is one good one. Why? The locators are placed away from one another. So, the second is an bad. Why? The top two locators are placed side by side and one is far away. And C also bad. See, the B and the C, the same. For the C, workpiece could rotate about the locators, they are placed too close together. So, that is the principle of location. That is the principle of location. Now, we will see the clamping. First, we are going to see regarding the principle of clamping. So, in order to achieve the most efficient clamping, the following factors must be considered. Now, we will see what are they: position, strength, procurity, operator fatigue, and the workpiece variation. I repeat, the position, that means in which position it is clamped, the strength, with the help of the clamp, how much strength it attains, productivity, by mixing of those how much we are getting output, operator fatigue, is the worker is able to do the works, workpiece variation, that means the change in the works. Position, the clamp should be positioned to direct the clamping force on a strong supported part of the workpiece. See, the clamping should be positioned to direct the clamping force on a strong, that support of the workpiece. In the figure you can see clearly the position of the clamp, tool, work, fixtures, clamping pressure, and here also you will see the tool, work, fixtures and the clamping pressure. So, first one is an bad and the second one is an good. So, what is happening here? See, the clamping pressure in the bad we will see from the left side, and in the good we are seeing the clamping pressure from the right side, that is of my side, and also you will see the tool movement there. So, in that way we have to make a position of a clamp. I think you are understood. So, see the position of the clamp here. Right, slotted, strap, clamp. So, clamp movement. So, it is fixed. Strength. The clamp should be capable to holding the workpiece securely against the forces developed during the operation. So, the clamps which we are using during the operation, they should attain a good strength. If not, it may get variation in the accuracy. So, that is why the workpiece it should be kept to secure against the force developed during the operation. See in the figure, strap clamp, the pot and the gooseneck clamp. So, what we are doing while performing the operation, the part should not get moved or the part should not change its position. So, that is why the clamp should attain the strength. And see here the clamping force. Here for the cylindrical object or for the cylindrical pipe, it has been clamped in 4 sides. This is also the same figure. See in this figure with the pot clamping screws 1, 2, 3, 4, 5, 6, 7, 3, 4, 8. Total 8 clamping screws are there. So if we kept like this, the clamping will get a good strength and the part do not move. See in the solid figure, strength. Here also you can see the help of an G clamp. Productivity. Clamping time should be minimized by using hand operated clamping devices. The clamping time should be minimized by using hand operated clamping. What are the hand operated? That we will see now. The first one is an handle, hand knob, second one, third one null head and tommy bore. So these are all called hand operated clamping devices. So thus as that we can move the jaw or the clamp easily. We can move it easily. So operator fatigue. If a considerable number of clamps are to be tightened and loosened repeatedly, it is an advantage to use the pneumatic or hydraulic clamps. So what is telling? If we use the mechanical clamps, so if we repeatedly make the tightening or the loosening, it may become weak. So this is the main advantage for that one. So by using the pneumatic or the hydraulic clamps, that is a good advantage for that one. So for the repeated operation, we have to go for the pneumatic or the hydraulic clamps. So you can see the pneumatic clamp on the screen. I will make a zoom such that you can see clear. This is a pneumatic clamp. So hydraulic clamp, I am making a zoom. So that is best suited for holding cylindrical objects. Both jaws, those are movable. So the workpiece variation. The clamping parts should be provided with ample radius to make the clamp operable even there is a variation in the workpiece. The clamping part should be provided with a sample radius to make the clamp operable even if there is a variation in the workpiece. So see the figure, you will see the workpiece variation. So workpiece, radius at clamping point, spherical wing nut, spherical heel in the bottom. So in this figure, so the clamp slightly inclined. So this is nothing but a workpiece variation, or the workpiece is kept something bottom on the table. So the workpiece variation here also you will see pivot pin and the equalizer are you are seeing there, and top you are seeing the clamp. So if we are use the unequal workpieces, we will get the workpiece variation there. So this is regarding the clamps. Now we are going to see the video that is regarding locating and clamping devices. The source is from the YouTube. It is by Mr. Sheet PC, Department of Mechanical Engineering, MVP, KBT, KOA, Nasik. He has given a excellent seminar regard on that one. Now we are going to see.
That is locating and clamping devices. First, we will discuss about degree of freedom of movement. The workpiece is assumed to have true and flat faces in a state of freedom. It may move either in two opposite directions along three mutually perpendicular axes, that is XX, YY and ZZ. These six moments are called moment of translation. Also, the workpiece rotates in either of two opposite directions around each axis clockwise and anti-clockwise. These six moments are called rotational moments. The sum of these two types of moment gives the 12 degree of freedom of workpiece in space. Here, the workpiece must be accurately and positively fixed in jig or fixture where the moments of workpiece in any of the 12 degree of freedom must be restricted. For that purpose, total 6 pins are provided. 3 are in Z axis, 2 are in Y axis, 1 in X axis. From the diagram, it clearly shows the position of these pins. The workpiece is rested on 3 pins which are inserted in the base of fixed body. The workpiece can't rotate about the axis XX and YY, and also it can't move downward. In this way, the 5 degree of freedom have been arrested. 2 more pins are inserted in the fixed body in a plane perpendicular to the plane containing those 3 pins. Now the workpiece can't rotate about the Z axis and also it can't move toward the left. Hence the addition of these 2 pins restrict 3 more degree of freedom. Next, another pin is in second vertical face of the fixed body, which again arrests another degree of freedom. From the diagram, it is clearly indicates how that workpiece is properly placed in that position. That is called as 3 to 1 principle. Next point is locating devices. First, we will discuss about the design principle for location. In that case, at least one reference surface should be provided from which subsequent machining will be measured. For ease of cleaning, locating surfaces must be as small as possible, consistent with adequate wearing qualities. The locating surfaces should not hold burr. For this purpose, proper relief should be provided. For the location of rough surfaces, adjustable type of locators should be used, and to avoid the distortion of workpiece, it is properly supported. And again, sharp corners in the locating surfaces must be avoided. For easy fall of chips and burrs, locating surfaces should be raised above the surrounding surfaces of the jigs and fixture. Now we will discuss about various type of locating devices. From the diagram, you can see that the locating pins. Now the first type of locating devices is support pins. In these support pins, there are 2 types. First one is fixed type and second one is adjustable type. In fixed type, a curved locating face on which the workpiece is supported, and in adjustable type, there is also a curved locating face and mainly used for variable dimension components. Also in this case, supporting pads and stop pins are used. Next type of locating device is jack pins. There are 2 types of jack pins, which are commonly used, that is spring actuated and wedge actuated. Jack pins are mainly used for supporting components of varying dimension. There are these two types of jack pins. First one is spring actuated jack pin. In this type of pin, there is a lock nut which is mounted on the screw. When the nut is rotated, locking pad moves forward and jack pin pushes workpiece upward. Second type of jack pin is wedge actuated jack pin. The bottom face of the pin rests on the wedge which is of tapered surface. By rotating hand nut, the wedge is pushed forward and with the help of tapered wedge, the jack pin is moved up to the workpiece surface. A return spring is provided on the other side of the wedge to push it back to the starting position when the hand nut is rotated in the opposing direction. Next one is the different types of locating pins. Locating pins are also called as pin locators. There are again three types of locating pins. First one is plain cylindrical locating pins. The shank of these pins is fitted in the jig or fixture body by pressing. The locating diameter is greater than the shank diameter and is push fit in the workpiece hole. Hence, there is a firm setting of the pin due to which the pin is not pushed into the jig or fixture by the weight of workpiece and cutting forces. Next one is plain cylindrical locating pin with collar. These types of pins are similar to plain cylindrical pin, only the difference is that these pins have collar which is provided to resist cutting forces while machining. These pins are also called as bullet nose locator. Next type of locator is conical pin locator. It is generally used for locating cylindrical components. Cylindrical locators are mainly used for cylindrical components of varying dimension. The conical shape, which itself carries a uniformly varying diameter of its cross section, takes care of this variation and locates workpiece centrally. Next type of locator is V-locator. In V-locator, again there are two types. One is fixed type and second one is adjustable type V-locator. Here we can see the fixed type of V-locator. It mainly consists of V-block with its face forming V in vertical plane. It is fixed to the jig or fixture body with the help of Allen screw and dowels. Next type of V-locator, that is adjustable type V-locator. In this type, it is operated by hand nut and the hand nut is mounted on the screw and provided with collar. A hand nut extends into a slot which is made in sliding V body. When hand nut is rotated, sliding V moves horizontally with the screw. The main body of the locator is fixed to the jig or fixture body, hence V-locator slide inwards or outwards in the body to locate that workpiece. The V-block should be used correctly so that the variation in the size of workpieces are not determined to location. Next type of locator is bush locator. It is widely used for cylindrical components like shaft, spindle, axle. Generally, that bush is made up of steel and then hardened and finished machined to close dimensional tolerances. For easy mounting and location, the locating faces of bush and clamp bushes are chamfered. After fitting to the jig body, they are secured with the help of screws to prevent their rotation and adjust the height of workpieces. They are generally used for drilling jigs. Next type of locator is diamond pin locator. Components which are having two previously finished hole are easily located by two cylindrical pins. These pins are projecting from jigs or fixture base which are used to engage each hole of the workpiece. Now you can see the diagram of this diamond pin locator. Here a workpiece is shown located on pin P, and for accurate location there is a small clearance between pin P and pin P. After correct location of this pin, the workpiece can rotate in either direction about the pin. Hence, due to the clearance between pins and holes, center distance between two holes and two pins does not remain fixed. Hence, to obtain accurate location of the workpiece, the relief is provided on the two sides of the pin. The main purpose of the relief is to allow variation in XX and YY plane. After providing the relief, the pin looks like diamond shape, hence it is called as diamond locator. Next one is clamping devices. Now first we will discuss the principle of clamping. It is used to hold the workpiece in correct relative position. The clamping pressure must only hold the workpiece and should never be great enough so as to damage, deform or change any dimension of the workpiece. The clamping and cutting forces should be directed toward the locating pins. Otherwise, the workpiece may get bent or forced away from the locating pins during machining. Clamping should be simple, quick and foolproof. Complicated clamps lose their effectiveness as they wear. The movement of a clamp should be strictly limited and if possible it should be positively guided. Whenever possible, the lifting of the clamp by hand should be avoided if it can be done by means of spring fitted to it. The clamp should always be arranged directly above the points supporting the works. Otherwise, the distortion of the work occur. Fiber pads should be riveted to clamp faces, otherwise soft and fragile workpiece can get damaged. Clamping pressure should be directed towards the point of support, otherwise work will tend to rise from its support. The clamp should be always be arranged directly above the points supporting the work, otherwise the distortion of the work can occur. Now we will see the different types of clamp. The first one is screw clamp. They are simple clamps and generally applied on the side face of the workpiece, thus leaving the top face free for machining. It carries a floating pad at the end to prevent workpiece displacement and to prevent screw deflection. The pad remains stationary on the workpiece while the screw rotates. Here you can see the actual screw clamp. The limitation of these screw clamps are clamping force is not same for all components. Relatively larger effort is needed for clamping. Time taken for this clamping is more, and it is if there is no floating pad, an indentation may be produced on the workpiece. Next type of clamp, that is hook bolt clamp. It is very simple device used for light work where other types of clamps are inconvenient. Next, we will discuss about the various types of lever type clamps. In that case, first one is breech clamp. In breech clamp, the clamping force is applied by the spring loaded nut. The relative position of the nut and the point of contact of the clamp with the work and the other outer support is important. The nut must be nearer to workpiece contact end than the outer support end for large fraction of the force to be transmitted to the workpiece. The spring is provided for automatic lifting of the clamp when the nut is loose to remove the workpiece. Next type of clamp is edge clamp. Edge clamp are also called as side clamp. It is used when horizontal surfaces are to be machined. Clamping and releasing of the workpiece can be done by operating the clamping nut. The next clamp is heel clamp. The heel clamp consists of a robust plate or step and a center stud and heel. The heel is provided on the end of the clamp to guide its sliding motion for the loading and unloading. There are different types of heel clamp. First one is solid heel clamp. In solid heel clamp, the heel is solid and one piece with the clamp. The clamp is constructed from rotation during clamping by a pin at the heel end. For loading and unloading the workpiece, the clamp is rotated through 90 degree. The clamp stud should at least be of 10 mm diameter and must be close to the toe end of clamp. Next type of clamp is latch strap or swinging strap. This is a special type of clamp which provides a means for loading and unloading the workpiece. For this, the latch or strap can be swing in or out. Next type of clamp is hinge clamp. It is similar to swinging latch clamp in which the latch and side movements are controlled. In this, the latch is fully open when the faces mark is contact. A hand nut is used to clamp the workpiece. Next type of clamp is wedge clamp. It consists of a movable wedge that forces the workpiece against a fixed top. The wedge has an angle of 1 degree to 4 degree for self-locking. Horizontal movement of the wedge produces a vertical clamping forces on the workpiece. Next, we will discuss about the different types of quick acting clamps. There are different types of these quick acting clamps. The first one is swing washer and sieve washer clamp. A swing washer is shown in that figure. It use of a nut smaller than the opening in the component. When the clamp is used, the workpiece can be unloaded without removing the nut. A sieve washer is used when the space for a swing washer is inadequate. This washer is chained to the base to prevent it from being misplaced. When used with a horizontal post locator, it is recessed to receive the nut, which will prevent it from falling from post during clamping. Next one is quick action nut. It is used when it is necessary to remove the nut to unload the workpiece. The nut is an effective time-saving device with interrupted thread. The nut is about 2 to 3 times the thread diameter in length and has hole slightly larger than the outside diameter of the thread. Next type of clamp is cam operated clamp. Cam operated clamp, there are again two types. One is toggle operated clamp. Here you can see that toggle operated clamp. Here a small fork movement produces a large clamp movement, but when the linkage is in the clamping position, a large movement at right angles to the direction of the clamping force is necessary to unlock the clamp. Here this is the C-frame type toggle clamp. In corner you can see how this C-frame type toggle clamp looks like. It is generally used where fabrication work is to be performed. Next one is Bayonet Clamp. It has a cylindrical cam partially threaded. A part of the groove in the bayonet is straight. The motion of the bayonet is guided by a spherical ended screw meeting with the groove in the bayonet. The bayonet can be pulled back straight axially through the straight slot to provide enough clearance during loading and unloading. These are all different types of clamps. Thank you. Thank you. Thank you.